Here we're going to talk about the angle similarity postulate, that side angle side similarity postulate, and the side similarity postulate. So you can prove triangles are similar by three pieces of information. So the first one is the angle. If two angles are corresponding congruent, or two pairs of angles are corresponding congruent, that makes the third one automatically congruent because all angles in the triangle have to equal 180. Therefore, it will make the triangles similar. So in the case, if you know angle S and M are congruent and R and L are congruent, it makes T and P congruent, which makes the triangles similar. So that's the angle similarity postulate. Next, you have the side angle side similarity theorem. So this says if one side ratio ABQR is the same as another side ratio ACQS, and the angle included A and Q are congruent, it makes the triangle congruent, or similar. Sorry, not congruent, similar. Yes, we do have a side angle side congruent statement, but now we're talking about similarity. Next, we have the side similarity theorem, which says if all three corresponding sides are equal in proportion, therefore you're going to have similar triangles. Because if all the side lengths are proportional, that means all the angles are going to be corresponding congruent. So instead of finding all angles and all sides for similarity, you just need to find two. So let's put it to use. So here we have a 45 degrees, and some people might say, well, we can't determine. Well, we can, because the vertical angles are congruent, which makes W and B congruent. So yes, we do have triangle SWR is similar to triangle S. What goes with W? B, V, by angle postulate. And here is our similarity statement. And our reason, by the angle postulate. Two angles congruent makes the third one congruent, therefore makes similar figures, or in this case a similar triangle. Next, are the two triangles similar? Well, first, okay, we're saying that L and R are congruent, and we don't know anything else, but we do know that triangles must equal 180. So this is 80 degrees, and this is 25. So they are not similar triangles because our angles are not corresponding congruent. So again, we can stop because we know all angles are not corresponding congruent, therefore they're not similar, and obviously they cannot be congruent triangles either. So are the triangles similar? If so, write a similarity statement. So we don't know anything about the angles. Well, we can check out the sides, which means you always compare longest to longest, short to short. So 15 is going to get compared to 10. We're going to see if it's the same as 12 over 8 and 9 over 6. So we have 3 halves, because 5 can go into 15 3 times over 2. Here we have 4 goes into 12 3, 4 goes into 8 twice, and 3 goes into 9 3 times and twice. So yes, they are similar by side similarity side similarity theorem. because all the ratios or the extended proportion is congruent. This is true. So here we have another one. You should notice that we have K, M, N. We have K, P, L. So K to M is 10, segment addition. K to N is 15. K to L is 8. K to P is 12. So you should notice right here they share an angle, so we know that these two angles are congruent. K is congruent to K. Now we just need to know that is 10 over 8 the same as 15 over 12. Well, we have 2 goes into 10, 5, 4, and then here we have 3, 5, 4. True. So we do have triangles are similar by side angle side similarity theorem. One more problem. This is called the indirect measurement. So we can use indirect measurement to find heights or lengths. Because if you know that this angle of reflection is congruent and you are perpendicular, you know that these two triangles are now similar by angle, angle. Since you know they're similar by angle, angle, you can set up your proportion. So we can have 5.5 over x equals 6 over 34. And when you cross multiply and solve, you get 6x equals 5.5 over 34. Cross multiply 5.5 times 34 and divide by 6, and you get 31.16. So x equals 31.16, or for those of you like correct, accurate answers, 187 over 6. So there's the proving triangles similar by the postulates and theorems of angle, angle, side, and side, and solving for variables using indirect measurement.